Hello, I'm Simon from Wheeled Tools. I'm here today to talk about checking tram on your CNC machine. Very simply, checking tram is checking that the spindle motor on the machine is perpendicular to the bed. You can buy proprietary gauges for checking this, but they're quite expensive. They use two dial test indicators that are close together, and so working out the numbers can be a bit tricky. So here's my method. You can make the gauge yourself, so you don't have to buy one, so it's cheaper. And it works over a larger area on the machine, which makes working out the numbers a bit easier, and it's easier to imagine what's going on as you do it. So here's my tram gauge. It's made from a piece of aluminium extrusion that I happen to have in the workshop. It uses an M12 arbor from Wheeled Tools, and I've simply mounted a dial test indicator to the end of it. You can make yours out of whatever you've got. It doesn't need to look like this. It can be a piece of timber with a router cutter in one end that you've press fitted into one end maybe. You don't even need a dial test indicator if you haven't got one. You can use something like a nail and some feeler gauges and measure down. This is simply a method to measure from the end of the trammel bar down to the machine. The trammel bar doesn't even need to be made that accurately. You don't need to worry about the angle that it comes out of the machine at, because the angle on one side will be the same angle on the other side, so you'll still get a consistent method. So here's my process. The first thing we do is skim the board on the machine. Now, if your machine is out of tram, you'll get marks, tram marks, obviously tram marks on the bed of the machine. That's what we're trying to get rid of. But for this process, you won't have got rid of those yet. So we need something after we've skimmed the bed of the machine to put on the machine that evens out those tram marks. Now, I use this piece of white corian that you can see in this photograph. I use that because I can write the numbers on it and that I've measured, and it makes it simple to keep a record. Now, you'll notice there's a dot in the middle of that piece of corian. That's because I don't know that it's the same thickness all the way across, but if I always measure down to the dot, the measurement will be consistent. So that's quite important. I should also say, when you put your tram bar into your CNC machine, you should isolate the spindle motor. The reason for that is obviously if you've got this tram bar in your machine and it starts going round at 24,000 RPM, that would be quite catastrophic. So make sure you isolate that. If you've got a vacuum bed and you skimmed the bed of the machine with the vacuum on, you will need to also take your measurements with the vacuum on, because when you turn the vacuum off, the board on the machine might cup or move in some way. So you should take the measurements with the vacuum on. You may have to turn the vacuum on and off to move the board around, but that's fine. So here's the process. Drive the machine to somewhere like the middle of the bed of the CNC. Isolate the motor. I mark my white piece of board with X, X and Y, Y, so I know which direction it is. I've deliberately made it oblong, rectangular, rather than a square, so that I can see which way it's orientated on the machine. But I mark that just so that I know, because when you start thinking about the numbers, you don't want to be trying to think about everything else as well. So you just need to make it simple for yourself. So get your tram bar in the machine, make sure it will spin all the way around. I measure across the XX first and mark that down, and then I measure up and down the YY. So you can see on the first photograph, you can see here measuring across the XX. So after you've carried that out, your board should look like this photograph with the measurements on it. Now you can see in this case that along YY, the measurements are fairly similar, they're close to each other, but across the XX they're out. So in this case, we need to move the spindle motor across to get those numbers to be the same. Now, because we're measuring over such a big area, we don't need to make our numbers exactly the same like we would if we were working with a very small tram gauge. We just need to get them close. I find that if you can get below 0.4 of a millimetre across the width of the machine, you won't see tram lines like you did before. You certainly won't be able to feel them, and you certainly won't be able to measure them on the edge of the board when you're cutting profiles. Just a couple of things to note, that when you're adjusting your YY axis, you have to do that by making shims that you put in between the spindle motor carrier and the Z axis carrier. You have to shim that out. I make my shims out of bits of Coke can that I cut up, and I use that for making my shims. Across the XX, it's a bit easier because you can just loosen off the bolts that hold the spindle motor to the Z axis carrier. You can loosen those off normally and move it enough. On some machines, and I know on my machine, I had to make I got a guy along the road actually to do it. I had to make the holes bigger in the spindle motor carrier so that I got enough movement, and I know a few people that have had to make those holes a bit bigger to get the tram right across the machine. So make your adjustments and then remeasure. I tend to cross out the number that I had to start with and write the new number next to it, just to make sure that you're going in the right direction. I felt that helps me in my head make sure that I'm going the right way. And it's a bit of a laborious process, but you have to keep doing it until you get to where you want to be. I would just reiterate, you don't have to be within 0.1 of a millimetre. 0.4 of a millimetre will be fine across, say a 4-foot machine using a tram bar about 500mm long like mine is. If you can get to something like that, obviously the better you can get it, the better, but you don't need to be absolutely 100% spot on to make the difference. I do find that when I go and measure a machine for somebody else, I often see them maybe 3 or 4 millimeters out in either direction, which is quite substantial and does make quite a lot of difference. And once you've got much closer, you can actually see and hear that as a difference in the machine. Anyway, I really hope that makes sense to you, and I hope at very least you'll be able to check for yourself if your machine is in tram, and I hope it will give you the confidence to tram up your machine for yourself and get it absolutely spot on. All these little details do make a difference to your machining, and obviously the better we can get the machine, the better our results will be. Thank you for watching. If you like my video, please give me a thumbs up, and if you want to see more like this, please hit the subscribe button. Thank you.